I'm going to make a few notes for question number 1 here on challenge set 24 about inverse functions. And we'll just look over the problem real quick together here. It says that we're going to consider this linear function. And all we're doing in letter A is making a table of an xy table for this function, basically. And then in part B, we're going to make a table for a new function g of x by switching the two columns from the table. I've done those two parts right here. And spoiler alert, g of x is the inverse of f of x, okay? Because it takes whatever the output of f of x was and it returns back the input that gives that output. So of course, this table was constructed just by plugging numbers in for x and getting the output of y. And so we've done parts A and B here, and I think that those two parts are pretty straightforward. But then some people are having some issues about the composite function. And so let me just start letter C down here, part C, and it says, using your tables from A and B, make a table for the composite function f of g of x. So now what we're going to do is we're going to make a new table, and it's going to take, if we're doing f of g of x. Okay, that's a composite function. So what I need to do first is whatever value of x I choose here, I'm going to first evaluate g of x and then take whatever output g of x gives me and plug that into f of x. This is the first table that I'm going to use. So I want to start with this x value. If I take negative 11 and I plug it into g of x, I get negative 3. And then if I take that negative 3 and plug it into f of x, it gets me back to negative 11. So when I put negative 11 in for x, I get negative 11 out from the composite function. Let me walk you through that again. Let's just choose negative 11 as our first value of x. And I choose that because it's right here in this table. And when I plug that x value into the function g of x, I get negative 3. And so this is negative 3 when x is negative 11. So I want f of negative 3 now. And that's f of negative 3 is equal to negative 11. So I get negative 11 out of this composite function. Look, we can do it again with negative 8. Right? Put negative 8 into g of x, get out negative 2. Negative 2, when you put that into f of x, you get back negative 8. And you know, we don't have to really do this much more, but you could do every value in the table over here for x, and you're going to see that we basically just get out the same x value that we got in. And that's also what happens here. Let's try this one. When we make a table for the other composite function, it's going to be, part D is asking us to make a table for g of f of x. Okay, so I'm going to evaluate f of x and then take the output of that and plug it into g. So I'm going to start over with this table right now. Let's imagine we start with the value of x equal to negative 3. Well, f of negative 3 is negative 11. So this is negative 11, and I want g of negative 11, and that gets me back to negative 3. And this continues. If I put negative 2 in to the function f of x, I get negative 8. Let me see. I start with negative 2. I get negative 8 out. I plug negative 8 into this function. I get back negative 2. And so on. Again, it's whatever you put into this composite function, you get out of the composite function. And that's a really interesting property of a function and its inverse. And it kind of makes sense that if you take a value of an input and you get an output from the function. Well, when you put that output into the inverse function, it gets you back to the input you started with. And that's all we're demonstrating here just by using these tables. So I hope that clarifies a couple things about challenge set question number 1 on challenge set 24.